Okay. So we stopped at 32. Okay. So today also you actually learned about a concept called consensus. So if you looked in the yesterday's class, actually, we also learned about the concept called consensus. Okay. So consensus, as you already saw yesterday, if the majority of the people agrees to a transaction, it means that everything actually happens in the blockchain. Okay, a transaction is actually valid. Okay, that's what a consensus means. Okay, so today you're going to learn about two concepts called validation and mining. Now you see when you talk with the people who are in the blockchain industry, generally people try to mix these things up. Okay, so people will say validation when they actually mean mining, and people will be talking about mining when actually they meant validation. So people actually use these things interchangeably, but you need to understand very clearly that these two are two different things, two different steps. Okay, so we are going to learn each thing in detail now. Okay. So the first concept that we are going to learn is called mining. So yesterday, I think Joshua, you asked me, I'm sorry, is it Joshua or OG, someone? Okay. So they asked me like when I'm actually going into this one. So when I'm actually using this platform as a demo, you can see that when I'm entering something and when I'm clicking mine, something is happening. And again, the block is turning from red color to green color. Okay. So yesterday, one of the students asked me, what does mining mean? So now we are actually talking about what mining means. Okay. So now let us consider uh, n number of possible hashes. Okay. So what does that mean? So let us consider this as a very big cylinder. Okay, so let us consider this as a very, very big cylinder. At the very bottom, okay, so at the very bottom, we have 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, like, 64 character length. Okay, actually, yesterday we learned that, alphanumerical string will be a fixed character. Okay, so we are saying that we have a 64 character length hashes. Okay, the bottom, the least one is all zeros, which means literally it is all zeros. Okay, and then on top of this one, so just on top of this one, you can see that it will be all zeros and one. And on top of this, it will be all zeros and two. Okay. So as you go from here to here, so somewhere else, you will get something like this number over here. Okay. So maybe you will get all nines. Okay, so this is somewhere in between. So all zeros and one, all zeros and two. So it's literally 0, 1, 2, 3, 4, 5, 6, 7, till you get something like a 9 trillion billion million number, something like this, 64 character length. And even on top of this, you'll be having, so on top of this, after all nines, you will be having all A's. Okay. So actually, in the alphanumerical values system, okay, so in the alphanumerical value system, now you can see the numbers from 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So total you have 10 digits. Okay, so from 0 to 9, you have 10 digits. Now A, B, C, D, E, F are also digits. So A will become actually 11, B will become 12, C is actually 13, D is 14, E is 15, F is actually 16. Okay, that's why they are called alphanumerical hexadecimal numbers. Generally, they are called hexa, which means 16 hexadecimal numbers. Okay, so this is what it is. Okay, so you can see all A's, and then gradually, the highest number that you can have is all F's. Okay. Something like this. Okay, so now you can see from literally from all zeros, if you go up, it will be all F's. So there will be many number of numbers in between this one. So there will be billions and billions of numbers in between these two higher ends. Like, this is the highest number and this is the least number, and in between you will have many numbers, many different combinations and everything. So maybe somewhere here, somewhere here you might have something like A1, 2, 3, CC, AA, BB, FF, something like that, okay, which is a number, which is maybe 2 million, 16,000, something like that. So again, if you look into this one, you might have something like 0000, AA, 2233311, something like that. Okay, so there will be n number of combinations in between this extremities, this one and this one. Okay, so this can be considered as the total number of possible hashes. Okay, total number of possible hashes. Okay, so these are the total number of possible hashes. Okay, now what generally happens is that the blockchain system, okay, so the blockchain system, so I will call this as the blockchain system. So generally, if we are considering something like a Bitcoin ecosystem, so what happens in Bitcoin is that it tries to generate a random hash. Okay, so it will try to generate a random hash. A random hash, maybe something like, AA11111000000000 something. Okay, so it actually generates random hash for every 13 minutes. Let's say 13 minutes or maybe 10 minutes or something like that. Okay, now this random hash, okay, and if you consider logically, I mean, let's try to divide this entire, this entire container into half. Okay, so let's divide this into half. Okay, now this random number or random hash that has been generated is nothing but a number, but in a hexadecimal value. Okay, alphanumerical representation. It's a number, but it is a hexadecimal value. Now this number will be either smaller than these things or bigger than this one, right? So it will be either smaller or bigger. Now what happens is that, okay, so Varma, OG, and Angel, so three people over here. Okay, so 1, 2, 3. 1, 2, 3. Okay, now these three people will try to play a game. Okay, so they will also generate random hashes. So Angela will also generate a random hash. Okay, so Angela will also generate a random hash. Similarly, myself, Varma, will also generate a random hash. And also OG will try to generate a random hash. Okay. Now, this random hash that has been generated by Angela, or this random hash that has been generated by Varma, and this random hash that has been generated by OG actually tries to compete with this hash. Okay. If Angela's random hash is more than this one, okay, so if that is more than this one, it means that she actually won the game. Okay, if my random hash is more than this one, then I won the game. If OG's random hash is more than this number, OG wins the game. If all the three has the hash which is more than this one, it means that whoever first got the random hash value, they are the winners. Okay, so we three are competing among ourselves to get a hash which is actually bigger than the generated hash by the blockchain ecosystem. Okay, so this is a very basic concept. Like you can just this is just for the analogy. Okay, I will actually explain the blockchain terminology and how this is actually implemented in the blockchain industry. I mean the blockchain domain. Okay, everyone can hear. Okay, so if anyone can't hear, please let me know in the chat box, or maybe you can unmute yourself and just let me know. Okay, because I'll be just carrying on with the topics, and maybe I will take a break after every 5-6 minutes just to see if everyone is okay with this or not. Okay, cool. So as I already told you, possible hashes, you have all zeros here and all Fs here. Okay, instead of FFF, I'm just writing 999. Okay, because it's a number easy for us to understand. Okay, so let's consider this as a pool of all the possible hashes. Okay, now as I already told you, when you go from this to the next one, it is like all zeros but one, all zeros two, all zeros three. So as you go on to the top, you will get all the numbers. Okay, a combination of all the numbers. Now this is a target hash. So as I already told you, blockchain actually tries to generate a random hash every 10 minutes. If it is Bitcoin, every 10 minutes. If it is Ethereum, every 10 seconds. Okay, so if at a particular period of time, it tries to generate a new hash every time. Okay, so something like you can see if the lower limit is all zeros and the upper limit is all nines, maybe blockchain will try to say generate, and it will get a number like this. Okay, again it will try to generate after 10 minutes, again it will get a number like this, again it will try to generate, and again it will get a number. So for every 10 minutes, if it is Bitcoin, or if it is Ethereum, for every 10 seconds it will try to generate a random hash. Generally, without, there is no logic behind it, it just tries to generate a random hash. Okay, now system generates randomly. Okay, blockchain system actually generates randomly. Okay, so what is happening is that, sorry, what's happening is that now Angel will also generate a random hash, Varma will also generate a random hash, OG will also generate a random hash. So this random hash should be less than this one. I think I said it should be greater than this one, but just a correction. So the number that has been generated, or the hash that has been generated by the participants like Angel, Varma, OG, Joshua, Christabel. So the numbers that you have generated, it should be less than this one. Okay, so it should be less than this one. So if it is in at this level, okay, let's say if the thing that has been generated by the blockchain is at this level, so the hash generated by Angel should be less. It could be anywhere here. It could be anywhere here, but it should be less than this. Okay. Similarly, Varma's should also be less than this one, or maybe more. If it is more, it is automatically rejected. So it should be less than this one. And if it is OGs, it should be less than this one. So whoever gets the less value compared to the target value, they are the winners. Okay, so I will tell you what does winning means. Okay, so what can be done for getting the target hash? So you see here, when I'm saying actually, so let us say this is the hash here and this is the level. Okay, so this is the random hash. Okay, now when I'm trying to say the random hash, okay, so when I'm trying to say random hash or something like that, how do you get a random hash? I mean, you can't go to a number generator and you can simply click on generate random number and you'll get a hash. Okay, so there should be some sort of logic behind it. So there should be some sort of basic dynamics behind it. So how do you get a random hash? Now let's go back to the block here. Okay, so let's go back to the block here. You see, we have a block number 1, which we cannot do anything about it. So block number is already decided or predefined by the system. So we cannot do literally anything about it. Now, nonce, as I already told you, number only once is a random number, but we can change it. Okay, random number can be changed. It. Okay, I will not explain this now because I will ask you a question on how we can use nonce, and I think you will answer that. Okay. Now, data. So when I'm actually talking about data, what does that mean? So data is nothing but the transactions that are happening. So even in yesterday's class, you can see that each block just contains the data. So data of persons actually transacting between each other and all that stuff, right? So even here, the data is nothing but the transaction that happened. Okay, so maybe I can say Verma sent 100 units to Angel. Okay. Similarly, OG has sent 20 units to Joshua. Okay. And Christabel have sent 30 units to Hypo, something like that. Okay, let's say. So these are the different types of transactions that actually happen. Okay, so to be very, very clear, if I go to this one, so you can see the block number 1, the nonce and the transactions. So this is the amount from so and so person to so and so person. Okay, so you can say instead of Darcy, you can say Varma has sent this to Angel. Okay, and Joshua sent some money to OG, and Hypo has sent money to Christabel, something like that. Okay, so there will be different types of transactions in here. Okay, and previous hash is also something that we cannot decide because, as you already saw, previous hash is something that is connected to the previous block's hash. Okay, now this hash is also not something that you can create. So this hash is actually generated depending on this data. So the block number, the nonce number, all the transaction details, the previous hash. So when you combine all these things together, this hash will be generated. Okay. So when you combine this block number, nonce, and all the transaction details, you will get this hash. Okay. So if Angel is actually working on this block, okay, so if Angel is trying to work on this block, after entering all the details about the transactions and everything, she will get a hash here. So that hash is nothing but the random hash I'm actually referring to. Okay, so you can see this random hash is nothing but the hash that has been generated with all these details. Okay, maybe if I am using this block from my computer, the transactions that I enter here is nothing but the random hash that I generated. So this random hash is nothing but the block hash generated by the data of my block. Okay, random hash generated by the data of my block. Similarly, random hash of OG will be same. Okay, now this hash will be compared with whether it is greater than the target hash set by the blockchain or lesser than the target hash set by the blockchain. So that's how we actually compete with each other. Okay, so this is the way people actually try to compete with each other to get some rewards. So why would people get rewards? Because someone is trying to enter all the data into a block and they're trying to make it validated. That's the reason why people will try to pay you some money because you're trying to do some work. Okay. So that's why this is called proof of work. Because you have done some sort of work, this is called as proof of work or POW consensus. Okay. It's called POW consensus. Okay. Now, there is a major problem over here. Okay, so I will explain the concept of the data and the transactions. Okay, so what generally happens is that, let's go here. Okay, so what generally happens is, I'll just copy this. Okay. Um, Okay. So I'll explain another concept here. Okay. Now you see there are the different types of transactions values here, and someone is actually sending money to someone. Of course, this will be not a name, but it will be a hash. Okay, this will be our address. Instead of forma, it will be an address, which is something. It will look like something like 1 2 3 4 AA CC, something like an alphanumerical value. Even angel, there will be no name of angel, but a hash or address, which is nothing but an hash. Okay, so all these are actually encrypted, but just for you to understand the concept, we are actually writing in this way. Okay, so don't get confused again why the names are there in the transactions. Generally, the transactions, everything is like encrypted. Okay, so even if you go to the main platform Etherscan, where you can actually look into the transactions. So if you go to Etherscan, okay, so you can see latest transactions. Okay, view all transactions. So you can see all the transactions from so and so to so and so, the value this one. So you can see different types of transactions that has been happened over here. Okay, so different types of transactions happen. Okay, so in the back end, what happens is that when a transaction actually happens, so if you consider just this one. Okay, so if you consider just this one, okay, so if you consider just the first one, okay, I'll just try to maybe create this one. Okay, if you just consider this transaction, let us say this is transaction 1. Okay, similarly, the second one is nothing but the transaction 2. Okay, the third one is transaction 3. Like that, you will be having different types of transactions. Okay, now in the blockchain, there is something called a pool. Okay, so this is called as this is called as a memory pool. So what does this memory pool do is that, so now this transaction that has been done in the blockchain is actually kept in this mempool. Okay, so it is actually kept in this mempool. Also, this transaction that has happened is also kept in the mempool. Okay, so different types of transactions are actually kept in the mempool. Okay, so the different types of transactions are actually kept in the mempool. Now, we who want to actually get the target hash, so we people, what we do is that, sorry. Okay, so what does we do? So what we actually go to the mempool and we actually select the transaction that we like. Okay, so instead of selecting from 1 2 3 4 5 this, we will try to select the transactions that we like. Maybe I will pick up this transaction, the first transaction, the third one, the fourth one, the seventh one, the eighth one, randomly. It depends on my choice. I can actually select any one. Okay, and even Angel will try to select maybe 2 4 6 8 9 11, something. It's up to her. Even OG will try to select their own transactions. Okay, now if you take my example here, okay, so I selected transaction 3. So I selected transaction 3, transaction 1, transaction 3, transaction 1, transaction 2. So after I have collected all the transactions, what I will do is that I will try to keep all those transactions in my block. Okay, so my block will look like this. So I will enter transaction 1 details, and then transaction 3 details, and then transaction 2 details. Okay, like that, I will try to select few transactions from the memory pool and I will try to enter in my block. Okay, I have entered that in my block. And then when I entered my block, I actually got this hash. Okay, now this hash, I will try to compete and I will try to see whether that hash is actually less than the target hash. Okay, Even Angel will also do the same thing, but instead of these three transactions, she might select different set of transactions. OG will also do the same thing. Joshua will also do the same thing. Christabel will also try to do the same thing. Okay. So we all can be considered as miners. Now we are not validators again. So we are actually called as miners. Okay. So we are miners. Okay, so we have our own block, we are getting the transactions and everything, and we are trying to generate a random hash. Each will have their own random hash, and we'll try to see whether that random hash is less than this one or not. Okay, so whoever gets the first random hash or the block hash which is less than the target value, that means they have won the game. Okay, so if I have got the thing, I am the winner, and the system will call me as the person who actually mined the block. Okay, so now I from miner I am become a mine. So I'll be called as the mined the block. Okay, so this process is called as mining. Okay, so mining is nothing but I'm trying to create a block with a set of transactions from the memory pool, so that I can actually get a block hash which I can compete with the target hash that has been generated by the blockchain system. Okay, if I get the if I get the random hash less than the target hash, that means I mined the block. Okay, so this is what mining means. Okay. Yeah, all good. Can I continue? I know this is complicated because it's a very blockchain is a very complicated concept, but I think this is a little bit clear. If you need, I can actually explain again briefly. Otherwise, I can continue. Is everything okay? Christabel, OG, Joshua, Angel. Yes, cool. Thank you. Others, are you okay for me to continue? Angel is typing. Okay, I'll wait if she has any questions. I think if you have any questions, this is the right time to ask, because once we go further into the concepts, I think it will be a little bit complicated. It gets more and more complicated once we go into the journey, right? Again, I didn't get some part. Okay. So I'm gonna explain briefly. Okay, I'm not gonna. I think I can't explain this one. Okay, but I'll think I can do it briefly. So let's say three people now coming are trying to mine the block. So what does mining mean? So now three people has come forward. So Angel, Varma, and OG. These three people has come, forward to actually mine the block. What does mining mean is that, so you see, there will be different transactions that are happening in the blockchain. Okay. So maybe I'm sending some money to Angel, Joshua is sending some money to OG, Hypo to Christabel, Lady Kathy to Colin. So there will be different types of transactions over here. Okay. So when the transactions happen in the blockchain, actually, they are saved in a thing called memory pool or mempool. Shortly, they are called as mempool. Okay. So everything is actually saved in memory pool. Okay, all these things are actually saved in memory pool, like transaction 1, 2, 3, 4, 5, 6, like this one, this one, this one, this one, individually. All these things individually are actually saved in the mempool. Now, three of us who actually come forward to actually try to mine the block, what we'll try to do is that maybe Angel will try to pick up randomly three different types of transactions. So transaction 2, transaction 1, and transaction 3. Okay, so similarly I will also select different transactions, or maybe the same transactions, up to me. Okay, so I can select the same ones or maybe something similar. Okay, and even OG will select his own set of transactions. Okay, maybe transaction 1, transaction 7, transaction 6, or other combination. Okay, so something like that. So we will select different types of transactions, or we can select the same transactions. So what we will try to do is that now each one of us have a block with us. Okay. So each one of us have our own block. So OG has his block in his computer. Varma has his block in his own computer. Okay, so this is my block. Okay, so this is mine. This is Angels, and this is OG's. Okay, so we have our own blocks. So now what OG will do is that OG will try to enter these transactions in here. Okay, so he will try to enter these transactions over here. So transaction this, and transaction this. Okay, so in his block, he will try to enter the transactions in the data field. Now, as I already told you, block number is something that has already been predefined. So you cannot do anything about the block number. So it is fixed. Now, nonce is a random number which is already predefined in the blockchain, but you can change the nonce. It's up to you. You can change the nonce. Okay. Now, this data is also in your hands. When you actually enter different transaction, you are getting different type of data, which will actually generate this hash. Okay. Now, this hash that has been generated due to your selection of the transactions, this can be considered as your hash. Okay. So this is OG's hash. Okay. So he has actually created a hash. Now, what happens is that, okay, now the hash that has been generated by OG, he tries to compare. Let's say he has generated the hash. Okay, so the hash is nothing but the value of the hash is nothing but 1,000. Let's say 1,000. Now, blockchain has created a random hash, and the value of that is actually, and the value of that is actually 1,200. Okay, so this is the hash that has been generated by the blockchain, and this is the hash that has been generated by OG, depending on his selection of the transactions. So now what happens is that 1,000 is actually less than the target hash. So because OG has actually generated an hash which is less than the hash generated by the blockchain, now it means that he is the winner. So he has actually won against Angel and Varma in actually mining the block. So because he got the value, he got the block hash, he is the winner. So he's the one who actually mined the block. Okay. So this process, entire process is called mining. Okay. So mining is a process where people select different transactions and they will try to combine all of them together, and they will try to keep in a block so that you will get a hash, and that hash will be compared to the target hash set by the blockchain. If the hash is actually less than the target hash, it means that that particular block has been mined. And the person who actually created who has actually the one is he's called the miner. Okay, so this is the concept behind mining. Yeah. Joshua, do you have any question? Mm. Okay. So that's the concept of mining. Okay, so why we need to do mining is, this is a decentralized network. Okay, there is no politicians, there are no teachers, there are no other people, right? So we need someone to do the work even without us telling that, hey, you need to do the work, because this is decentralized. I think there should be decentralized mechanisms where people will be incentivized to actually do the stuff. Okay, so that's the reason why mining actually happens. If mining doesn't happen, what will be there? The transactions will be getting on collected on the mempool, and no one will try to do any work, and the system will not go forward. Okay, so that's why there is a process called mining, where people will try to select the transactions from the blockchain. They will try to keep that sorted, everything. They'll try to check whether everything is clear or not. And then if he won the game, he will actually be rewarded with the coins. If it is in Bitcoin ecosystem, he will get Bitcoins. If it is in Ethereum, he will get Ether. Okay, so that's how we incentivize the people who actually does the work. Okay, so is that clear until this point? Mining. I think OG, okay. Angel, did you get it now? Is it clear now? Joshua, Christabel?
Yes, please, I'm okay now.
Cool, thank you. I think Joshua is in the, I think has a noisy background, so he's not speaking. But okay, I think I'm guessing that everyone got the point now. Okay, so this entire process is called mining. Now, this is a very complicated concept. Okay, if we go into more detail, it will be more technical and more mathematically cryptographical. It will be more complicated. But I thought, okay, that's not needed because it's not needed for everyone. Okay, in real world you will not work with this, like 98% of the people, there's no need for you to understand these things, but it's better to actually understand the concepts, because if anyone tries to speak about these things, you can actually talk about like what is mining and the other stuff. Okay, so this is the concept of mining. Okay, now what can be done for getting the target hash? Okay, so I will just ask you a simple question. Okay, I'll just try to ask a simple question now. Maybe it's like a quiz. Okay, so okay, I'll go here. Okay, I'm gonna ask you this thing. Okay, now this is the block. The block number, as I already told you, is fixed, and the data you're selecting the transactions 176 something like that, and you got this hash. Okay, now let us consider a scenario, a hypothetical scenario where no matter how many different types of combinations you're trying to enter, like maybe you selected 1 2 3 1 4 7 or maybe 1 6 5, so you're trying to use different types of combinations available, but even then you're not trying to get the hash which is actually less than the target hash. Okay, so you have tried like millions and millions of combinations. So a computer is actually capable of doing thousands of permutations and combinations per second. And if you can imagine, if you have a supercomputer, you can actually do millions and billions of permutations and combinations per second, right? But even then, when you're trying to enter all these things, you're not getting the hash. So what can you do? My question is, what can you do even if you entered all these things, you're not getting the target, I mean, you're not getting the block hash, which is less than the target hash. So what can you do to get the actual number? Any guesses? Any guess? Anyone knows how? Even though you're trying to give different types of transaction combinations, you're not still getting the block hash. Okay, so just guess, what can you do to get this thing? I'll just give you 1 minute. Maybe you can think about it and just let me answer. So I'll just see like if you can get the answer.
Please, can you ask the question again? I don't understand it. Like, I didn't get the question.
Yeah, so what I'm trying to say is that, so you have a block here. Okay, so let's say OG has his block. Now the block number is something that has already been fixed. So block 1, block 2, block 3 is already fixed. So you're just working on the latest block. That's good. Now you have nonce, which is a random number, but which you can change, and you can change according to your wish. Now the data, as already told you, that it is nothing but the transactions that you have selected from the mempool. Okay, so OG have selected some different transactions from the mempool and he has entered in the data field. Now based on all this data, now you're getting this hash. Okay, now you know that this hash you will compare with the target hash, and if this hash is actually less than the target hash, that means you have won the game. Okay, now my question is, no matter how many different combinations OG is trying to use, so he used transaction 176 or maybe 143 or maybe 125, something like that. So he has used different types of combinations of transactions, but even then he's not getting the hash. So what can he do to actually get the hash? the thing that it's like a lottery, right? The one which can get him the, the rewards. Actually, did you understand the question again? Okay, I think I will not bother you about this. So you see here, as I already told you, nonce is nothing but a random number that can be changed. Okay. So when you're not trying to get different types of, when you're not trying to get the hash, even when using different types of transactions, what you'll try to do is that now you'll try to change the nonce so that maybe you can get the hash that you want. Okay, even after trying all the combinations, maybe the nonce is something that you can control, so you'll try to change the nonce accordingly. So depending on that, maybe you can get the the hash. So in here, after transaction 132, I will try to change this one here. Okay, maybe I will say 001 or maybe 002 or maybe 0210, something like that, a random number. So maybe after changing this number, I will try to get this answer. Okay, so maybe I will get the actual lottery hash that I can win against the target hash, and then I will try to mine. Okay, so nonce is actually used for that purpose. Okay, so nonce is also called as number only once. Okay, nonce is actually called as number only once, which is a random number that you can actually control. Okay, now this concept, where because you're doing some sort of work, it is called as proof of work, because you're doing all this, big computations, big calculations and everything. That's why it is actually called as proof of work. Now when you actually learn about blockchain, or when you hear about blockchain, many people say that blockchain is actually secured by a puzzle, a mathematical puzzle, which you try to solve. Okay, if you read the articles or if you try to learn from the YouTube channels or anything, they'll try to say there is a big mathematical puzzle that people try to solve in order to mine the blockchain. So that mathematical puzzle is nothing but this thing over here. So that mathematical puzzle is nothing but this concept. Okay, so this hash, and you're trying to compete with this target hash. Okay, so this is the mathematical puzzle that they're talking about. Okay, so this is called proof of work. Now the next concept is validation. Now you have mined the block. Now mining is just you have won the lottery to actually include that block to the blockchain. Now the block has not been added. So if you go back here, okay, so you got all the details, and let's say I have won the block. Okay, I have won the lottery. Now this has been not added to the blockchain. Okay, so let's say okay, so block 1, 2, 3 is done. Now I've actually mined the new block. Okay, now mining doesn't mean that the block has been already added onto the blockchain. Now this block number is actually 4. Okay, and the block details are all in this one. Okay, the thing that I have won. Now mining doesn't mean that it has been added to the blockchain. There is another step or another stage called validation. So once you validate the block, then only this block will be added to the blockchain. So once it is added to the blockchain, you know that what happens. It can never be removed again. It cannot be tampered with, and it is immutable. Okay, so that's the concept. So this entire thing is actually called as consensus mechanism. Okay, where people try to mine and then validate and then add to the blockchain. Okay, so I'm going to explain what is validation. Cool. So guys, let's have a break of 5 minutes, okay? Because I think I need to drink some water and everything. So let's have a break for 5 minutes, and again we'll come back and we'll discuss about the following topics. Okay? So 5 minutes and we'll be back. Welcome back. Welcome back. So I'm back after a tea break. Cool. So, okay. So we have actually discussed about the concept of mining. Okay. So I'll be talking about the next topic called validation. Now, just to summarize, mining doesn't mean that you have added the block to the blockchain. Mining is just the 50% of the work. The other 50%, you need to validate the block. Okay. So what does that mean? So let's go to that topic and let's explain that. Okay. Okay. So now the concept is called validation. Now, I've been telling you a scenario where I actually mined the block. Okay. I got the hash, which is actually less than the target hash. But generally, you know that I'm not the only person who has a computer and who can get the target hash. So there will be thousands of people competing for this block. So definitely, I think more than one person is going to get the hash, right? The lottery hash where he can get the value sorted out, right? So there'll be definitely more than one person. Now, when there is more than one person who actually mined the block, what will be the happen, right? What could be the scenario there? Okay, so this is where validation comes into place. Okay, so validation is where, let's say, this is me. Okay, the red color person here is me, and I have four different types of tables. Okay, maybe instead of tables, you can consider these as computers or nodes. So as I already told you in the first class, nodes are nothing but the computers or the system that we use to actually connect with the blockchain. So this is node 1, this is node 2, this is node 3, and mine is node 4, something like that. Okay, now what I try to do is that I try to go to each and every node. So first I will go to this one and say, hey, I got the block mined, so I'm successful. And then again I will go to this person, and again I will go to this node. So I will go to each and every one, and I will try to say, hey, I actually got the mined block. Okay, now as you already know that if there are more than one person who has actually mined the block, what will be happening? There will be another person who will be also doing the same thing, right? Now the red color person is myself, and let's say the green color person is Angel. Now Angel also got the mind block. Now she will also try to go to each and every node, and she will try to say, hey, I actually mined the block. Okay, so now this is a game where people try to communicate their messages to all the participating nodes in the network. Okay, so what does that mean is that, okay, so Varma, Angel, so this is OG's node, this is my node. uh, yeah, this is Angel's node. Okay, so each one of us have our own node. Okay, now what I will try to do is that now I will try to go to each and every one. I will try to give the message. Okay, so I will try to say to Christabel, hey Christabel, I actually got the node. Also, I will try to say to Joshua, hey Joshua, I actually got the node. So I will try to compete with Angel in order to, propagate my message to the network. So this entire thing is actually called as a network. So the combination of the entire nodes all together is called as a network. Okay, network. Now in the network, we will try to compete with each other to actually get our answer to everyone. Okay. Now in this game, in this race, whoever actually can convince majority of the people, as I already told you in consensus, if 51% of the people convince to a particular person, it means that the entire other 49% will automatically need to compile to that one. Okay, So this means if I actually am successful in actually convincing Christabel, Joshua, and OG, or maybe not just Christabel and Joshua, I think I have already won, because out of 3 people, I actually convinced 2 people before Angel could convince the 2 people. Okay. So I'm actually trying to convince the majority before Angel could actually convince the majority. Okay. So whoever wins the game in this propagation of their messages, they can be called as a validator. Now, miner is different and validator are different. So both of them could be the same person, but generally both of them can also be different persons. So generally what happens is that there could be another person, okay, maybe my brother, let's say Hypo, okay. So let's say Hypo actually mined the block and he actually sent the information to me. Now I will try to go to and run to each and every person and say, hey, we actually got the block. Okay. So Hypo is the miner and myself, Varma, will be the validator. Or sometimes most of the cases, miner and validator both can be one and the same. Okay. It doesn't matter, but you know what's the difference between a miner and a validator. Okay. So this process is called as validation. So validation is the process where a single node that has mined the block tries to propagate that message to the majority of the nodes in the network. Okay. So if the majority of the nodes agree to my message, it means that I have won. I mean, I have validated the block. So once the block has been validated, mined, and then validated, it will be added to the blockchain. Okay. So the block will be added to this one. Okay. So that's how a new block with new data will be added to blockchain. This concept is universal in every existing blockchain. Okay, so this concept is universal, like every blockchain has the same concept. The concept of mining, the concept of validation, the concept of adding to the block. So all this together is the same. Okay. Oops. Sorry, one sec. Okay. So did you understood the concept of validation and mining? So you can see this is validation. So it's generally called first past the post system. So whoever, runs first and tries to communicate that message to the other people, they are the winners. Okay. So, like why? Because, yeah, the other thing here is that why would anyone try to communicate their message to the other people? Like what's the tip for them? Like why would anyone do that? As I already told you, when I'm actually sending some transaction to the other person, I will also send some amount along with it. Okay, that is called as reward fee. Now, when I send that reward fee, people will try to, I mean, if the validator validates the block, he will get all the rewards. Okay. So because of that fee, he will be rewarded. So for that reason, he will try to do the validation, the mining and all the other stuff. Okay. Just to get the money. Okay. So this is why someone will try to do the validation or the mining. Okay. So generally, I will show you one thing. So, okay. Now you see, I'm sending some value to another person. Okay. I'm sending some value to the other person. And the value that I'm actually sending is something like this. Okay. I'm sending some value to this one. Okay. I'm sending this value here. Now you can see here, the network fee is actually zero, but generally the network fee will be something. Okay. Maybe $0.002, $0.003, something like that. Once I confirm, the transactions will be happening. And now you can see I can actually have some sort of reward point. So this is the transaction that has happened. Okay. So you can see there is some fee here. Now this fee is nothing but the fee that will be collected by the person who actually mined the block or the validated the block. So you can imagine a single block might contain something like hundreds of transactions. And the person who actually picks all these things together, and when he tries to validate the block, he will actually get all the reward points. Okay. So if you go into the real world use case, you can see here, if this is the transaction, from this person to this person, you can see the value is actually 0.011 ETH, which is nothing but $50. And the transaction fee, the fee that will be rewarded to the person who actually validate the block, it is nothing but $0.17. Okay, so this is just for one transaction. So if you consider for a block, generally if you consider for a block, you can see transactions, there are like total 109 transactions. Each transaction, even if you consider each transaction as 0.17, you can say that you got something like $17. Okay, generally. But you can see the base per fee gas. So these are the block rewards. Okay, so the person who actually done has actually got this block reward. Okay, 0.004937, which could be something like $20 or something like that. Okay, so this is how the validator or the miner actually gets the points. So this is the reason why someone tries to do the transactions or someone tries to do this stuff. Okay, so this is what it is. Oops, sorry. Okay, so that's the concept behind it. Okay, any doubts until this point? I think this is the most complicated stuff until this point. I think the others will be a little bit okayish, little bit easier, but this is the most complicated in the blockchain. Like there are 4 or 5 concepts which are very complicated in the blockchain ecosystem. Okay, and this is one among them. I hope everyone understood this process of validation and mining. Yes? No? Maybe? Can you give me some sort of answers, please?
Please, can you explain the validation again? Like my network was missing.
Yeah. Can you? Can you tell me which part did you not understand about the validation?
So in the middle part when you were showing the pictures of how the transaction was made and all this stuff, I didn't hear anything. My network went off. So I didn't get that side.
Okay. Okay. So my question is, did you understand the mining process? Like the mining, what does mining mean?
Yes, please, I understand.
Okay. So mining, after mining has been done, what happens is that, okay, now so this is me, okay, the red color the person is myself, Varma, okay. So I have the block mined, okay. So you can see I have actually, where is the block? So I actually got the mined block. Now what I'll try to do is that I will try to go to each and every person in the network, okay. So now what I'll try to do is that I will try to go to each and every person in the network. Okay. So I will go to Christabel and say, hey, Christabel, I have got the block mined. And then I will go to Joshua and then I will go to OG. So I will try to go to each and every person and say, hey, I got the block mined. I'm saying very generally, but in real world, it is your computer trying to communicate with the other computer and say, hey, this has been mined. Okay. It's just a message that will be sent from one computer to the other computer. Okay. So I'm trying to compete. Okay, so now whom I'm trying to compete? I'm trying to compete with Angel. Now Angel has also got her own mind block. So she also had a lucky, lottery ticket. Now I also have a lottery ticket, and even Angel also have a lottery ticket. So we both try to communicate, or we both try to go to each and every person and say, hey, we got the lottery ticket. Now, the person who actually tries to convince the majority of the people that they have got the lottery ticket, that person will be the winner. Okay, so if I went to, let's say out of 10 people, if I have reached 6 people and say, hey, I actually got the lottery ticket, it means that everyone, the majority of the people agreed to me and I'm the winner. If Angel gets the things done first, like if Angel convinced the 6 people before I could do, it means that Angel actually won the race. Okay, so it's just a race between me and the other person, or a miner and the other miner. Okay, two people try to, or two computers try to compete with each other to actually get this thing, send the information to all the other people. Okay, so I want my block that I told to everyone that, hey, this is the actual block. That block will be added to the blockchain. Okay, so you can say this block that I have said to everyone will be actually added to the blockchain. So once you add it to the blockchain, it is in the system. No one can change anything or no one can do anything about it. Okay, so that's how people compete with each other. Now, this competition and this propagation of messages to the other nodes is actually called as validation. Okay, so mining comes first. After mining, validation comes second. Okay, after validation, the block will be added to the blockchain. Is it clear now, Christabel?
Yes, it's clear now.
Cool. Okay, so I'm going to ask the question now. So OG, I think you're clear. Christabel, okay. Angel and Joshua, is it clear? You there? Angel, Joshua?
Yes, it's clear.
Cool. Thank you. Thank you. Joshua, I think you're very silent today. Is everything okay? I think just Joshua is typing something, so I'm just waiting if it's a question or something like that. So let's see what it is. Okay. Meanwhile, Joshua is typing. I think we just have 10 minutes of the class. Okay. So I'm not going to continue with the next topic because I think that's a too much information overload for you for today. Okay. So I'm not going to bother you more. I know, it sometimes the information will be so much that it's better to stop here. But I think OG asked a question yesterday in chat box. Okay. So he asked something like, how can we get jobs in blockchain? So I just want to say, like, what are the skill sets that you need and how you can get jobs in blockchain and the industry. Okay. So for this, now see, blockchain, to get blockchain, you need to understand coding. Definitely, you need to understand coding. Okay. Blockchain coding is different and the other coding is different. Okay. So coding are like two different types of things. One is something where you can create a website, like the front end of the website, the look and feel of the website, the connections, the API calls, all this stuff. So this comes under traditional software coding. Okay. I'm trying hard to focus on transit my investment. I got the ISO, but the mining part is still beta. Okay. Joshua, I think we will post the recorded class once. Have a look into it. And if you still feel problem with that, maybe you can let me know next week and I will try to, maybe come up with something. Okay. I think because you're in transit, maybe you couldn't hear properly, but yeah, don't worry. I think the recorded session will be posted. Okay. Yeah. Now, coming back to the topic, so there are two types of coding. That's what I was trying to tell you, right? So traditional software coding is something that you need to understand how to code the database, okay? How to connect with the database or how to write a web page or website or something like that, okay? That's the traditional thing. Now, blockchain coding is something where you need to understand how to actually write smart contracts, how to interact with the smart contract, how to connect smart contracts with the real world cases, how to write oracles. I mean, we will be learning about all these concepts, but how to write oracles, how to do all this stuff. Okay, so this is about blockchain coding. Okay, so these are two different things. Now, in our cohort, in our blockchain smart contract development class, we'll be talking everything from A to Z, zero to hero, all the concepts about blockchain coding. So you will understand everything about blockchain, the theory, the practicals, and like the other stuff. Like Solidity, which is the language that we use for smart contract writing. So you will understand all these concepts. Whereas the traditional software coding is something that I think you need to work on yourself, because I think you might need to, see for yourself like how you can get the things out of it, because mostly we'll be concentrating only on the blockchain part, not on the traditional part. Okay. But you need to know both of them to get the job, even if you want to. Okay, otherwise we're going to get back to you if it's sure. Okay. So you need to understand both the coding sides, like the traditional side and also the blockchain side, in order to be placed in a job. Okay, that's compulsory. That's the basic that every company tries to, they will try to expect from you. Like you need to understand coding and everything. And on top of that, you also need to understand the concepts. Now, you see, blockchain is something which is very, very new to many people. Like all the people who are using blockchain, they don't know many things about it. So you need to understand the concepts. Okay, it's not like you just vaguely study something and you don't understand the concept. You just try to say, okay, I understood the concept. So that's not how it should be. I think you need to understand each and every concept in detail, like what is mining, what is validation, what are transactions, what is the message value, what are the block, what is blockchain. So you need to understand each and everything in detail, because the people who knows about this information is very, very low. Like I think only 1 or 2% of the entire software community knows about these concepts. Okay, so you need to also understand that one. And fortunately, we will explaining all those concepts in detail in the classes. So I think most of the things will be sorted out. Next is actually building the project. So you will also build the projects in our class. You will try to deploy that into GitHub, which is a repository that we will be using and everything. Okay. So you need to show to the world that what you're trying to build. Okay. I actually tell to many people that, hey, whatever you're trying to do, just try to document in maybe LinkedIn or maybe in, something like Instagram. But many people don't do it. So when you don't try to do that stuff, like when you don't try to tell the world that, okay, you're trying to build something, how would anyone know? Like, how would anyone understand that you're building something? They would not know, right? So I would prefer everyone from day one, literally from day one, whatever you are learning in the classes or maybe in the articles or from the YouTube or whatever the resources that you are trying to learn, try to document it or try to summarize it in a short form and try to post that in a social media platform, maybe in LinkedIn or maybe in Facebook or maybe somewhere. Okay, somewhere where people try to search you. So actually recruiters try to search the developers in LinkedIn or maybe in Telegram channels or maybe in Discord channels. I think many Web3 companies have Discord channels. So try to post that information in those channels. Okay, so that's how you try to make a name of you. So Web3 is all about your name. If your name is really popular, they'll try to communicate with you and they'll try to hire you. Okay, it's not like traditional software where you prepare a resume, you give that resume to the recruiter and they try to recruit. That's not how the Web3 world is gonna work. Okay, that's not how the things work. Okay, so you need to actually try to tell to the public what you're trying to do. Okay, what you're learning from the stuff and everything. So that's the best way to actually get recruited. Okay, so these are the few things in the blockchain industry, how you can be hired. Now I'll tell you very interesting thing. Yeah, so they will be creating the GitHub. I think it will be part of the class. So don't worry, everyone. You'll be creating the GitHub, which is like your portfolio, where you can show your portfolio to everyone, to the world. Okay, that hey, this is what I am and this is what I have done. Okay, so you can also do that stuff. Now, the other thing is that actually, if you're coming to the salary side, like what will be the salary range, the medium, salary range of the blockchain developer, I would not give you an exact number, but I would say the average salary of a smart contract or a blockchain developer is definitely higher than a normal traditional software developer. So definitely the blockchain developers earn more than the traditional software developers. Okay. That's the good news that I can say. Now you might be concerned about, okay, now because of this AI, can't we be replaced? The answer is that you can never be replaced by AI in the blockchain world. Now, why am I saying this? Now, you see, in traditional software world, if you do any mistake, you can actually revert back or you can change the mistake. Okay, you can actually try to delete the mistake and you can change something. But in blockchain ecosystem, it doesn't work like that. Once you have written something, it will exist there forever. So you cannot do a mistake. You cannot trust a computer, no matter how, you cannot trust an AI, no matter how advanced it is to actually write something like this, because in future, all the finance and all the related banking ecosystems will be built on top of blockchain. So no person in the world, no company in the world will take a chance to actually use AI to write smart contracts or to develop blockchain ecosystem. Okay. So you will be definitely having a lot of opportunities in the blockchain ecosystem. So AI can never take your job. Maybe it can ease your job, but it will never take your job, especially in the blockchain industry. Okay. So these are the advantages of blockchain industry. Now, if you ask me the disadvantages, the major problem is that, as I already told you, this is not like a traditional software development job. Okay, you need to really be known in the circles. Like everyone should know you. Like, okay, you are a builder. You're trying to do something. Generally, you need to do a lot of open sourcing. You need to help others to sort the things out. So you need to make connections. You need to talk with a lot of people. So that's how you actually get a job. So there is no one roadmap to actually get a job. Okay, so you need to do different types of things to get even a basic job. Okay, so that's the downside. There are no regular jobs in this one. You need to be someone who is special to actually get this thing sorted. Okay, but generally nowadays the trend is that if you look into the trends, the number of blockchain jobs are actually increasing in every country, especially in Africa, because if you can follow the news, the value of many African countries are actually depreciated, or because of inflation and hyperinflation, they are getting like very negative these things, right? So because of that, many African startups, many African tech entrepreneurs, they're trying to build banks and different financial ecosystems on top of blockchain. So the job market of blockchain industry, especially in Africa, is actually increasing day by day. So you can see that in Google Trends or maybe over the internet. So you can just search about it. So the future looks good. The present is also good. There are only a few disadvantages, which I think by learning, by understanding the concepts and everything, I think you can overcome the topics. Okay, so this is the entire ecosystem, or this is the entire roadmap for the blockchain developer and how to get a job. Okay, so I hope I answered your question, OG. I think this is what you were asking yesterday. Thanks. Yeah, I know. I think everyone is concerned about AI. I do agree with that, but blockchain and AI is a totally different concept. Okay, so developers in blockchain will be having more secure jobs compared to other people. That I can definitely tell you for sure. Okay, so yeah. So does anyone have any doubts? Let me know, or we can call it a day off. And again, we will meet next week, Wednesday, same time. Okay. So again, next week, there will be classes on Wednesday and Thursday. I think you'll be getting the calendar invite. Try to accept that invite so that you will get notifications